Alright, next what we're going to do is I'm going to basically show you what we call an algebraic proof. Should be fun. You'll have a fun time watching it. I wouldn't expect you to know this, but it's just a little proof for you to see some nice little things. So what I'm going to do is I'm basically going to take this and I'm going to complete the square. So I'm going to go ahead and go through the process. I'm going to group my variables together, move the constant to the other side, factor out my nice little leading coefficient. Remember, it is like division. So when you divide a by a, you get 1. When you divide b by a, though, you just get b divided by a. Next, what we're going to do is we're going to come in and we're going to take half of b. Well, half of b is going to be basically this. The way you can take half of it, again, like we talked about in the last example, instead of dividing by 2, you can multiply by the reciprocal. So what we'll get is we'll get plus b over 2a. And what we do next is we're going to go ahead and we're going to take this and we're going to square it. So I'll put b squared over 4a squared. Well, as you guys well know, whatever's inside your parentheses gets multiplied by your a. So when you multiply those two things together, b squared over 4a squared, and you multiply it by a, one of the a's will cancel. So you're going to get b squared. So I'm going to have to add b squared over 4a here. Well, what I'm going to do now is I'm going to go ahead and get a common denominator to put those two things together. So my common denominator, c's denominator, is 1. The other denominator is 4a, so I'll multiply the top and the bottom of this one by 4a. So it's going to give me, it looks something like this. We'll say negative 4ac over 4a, and then plus b squared over 4a. Now what we can do is we can go ahead and solve for x. Actually, I would go ahead and get rid of that nice little a first. So I would go ahead and divide both sides by a. However, as you can see, a nice little complex fraction here. So I'm going to go ahead and put those two together. Let me see where I am on this next page. If I put these two together, well, I'll go one more step. We get x plus b over 2a, in parentheses squared, is equal to, instead of dividing by that, I can multiply by the reciprocal. So I'm going to take both these and multiply it by 1 over a. So I'll get negative 4ac over 4a squared, and then plus b squared, 4a squared. So when you put those two things together, it should look a little something like this. At this point in time, what we can do is we can solve for x, and we can do that by taking the square root of both sides. When you do that, you'll get x plus b over 2a is equal to, remember this is going to be plus or minus, and we're going to use the quotient rule. And what I'm going to do, I'm just going to rewrite it a little bit. So I'm going to put b squared minus 4ac all over the square root of 4a squared. And then lastly, I'm going to go ahead and solve for x. So I will subtract that. So I'll get negative b over 2a plus or minus the square root of b squared minus 4ac. And then this is obviously a perfect square, so 2a. Alright, so basically what we're getting at is the quadratic formula. So if you just combine those two terms, since they already have a common denominator, you get your quadratic formula. Nice little proof there.